Hello, everyone, and we are going to look right now at chemical equations. First, let's look at the parts of the equation. You probably know here we have written this equation right here. You know the reactants are here on the left side. That's what reacts together. The products are on the right side of the arrow. The reactants combine and produce the products. Another piece of information that is really useful in equations is this little piece of information. The small s stands for a solid. So this is solid potassium. L stands for liquid, liquid water. G stands for gas. It's lowercase also. So solid potassium, liquid water combine to produce a gas hydrogen. And potassium hydroxide aqueous. It's an aqueous solution. AQ means it's dissolved in water. So those are all things you need to know about parts of a chemical equation. Now let's look a little bit more at this idea of chemical equations. When we have a chemical reaction, remember, atoms are not created or destroyed. We have conservation of mass. We do not create or destroy atoms. Therefore, all the atoms present in the reactants must be accounted for among the products. So if we start with one atom of carbon, we better end up with one atom of carbon over here. Balancing a chemical equation is making sure that the equation for a reaction obeys this rule. So this is not a balanced chemical equation. Let's go ahead and balance that. So typically, when we balance a chemical equation, we'll start with the most complicated molecule. In this case, it's probably the methane. It has 5 atoms in it, and that looks like one of the larger molecules. So when we look at methane, we have 1 carbon in the methane, and there is 1 carbon. Get my pointer out here. There's 1 carbon here in the methane and 1 carbon on the right side of the reaction in the carbon dioxide. There are no other carbons over here. So the carbons balance out. What about hydrogen? There are 4 atoms of hydrogen over here. What about on this side of the equation? There are only 2 hydrogen atoms over here. So here's what we do. We write a 2 in front of that water molecule. That will give us a total of 4 hydrogen atoms. There are 2 atoms times 2 in the whole molecule. That gives us 4. Now, let's look at oxygen next. We've just changed this molecule a little bit, the numbers of things. We're saying there are 2 of these. There are 2 oxygen atoms here, but there are also 2 oxygen atoms right here. That's a total of 4 oxygen atoms on this side. How many oxygen atoms on this side? Oxygen is only in this molecule right here, and there are only 2. So once again, we are going to put a coefficient in front, and that signifies that we have 2 oxygen molecules, a total of 4 atoms of oxygen on the left side of the equation. Now, when we balance the equation, we always want to make sure at the end that everything works out right. So we go back and we check. Carbon, 1 carbon, 1 carbon. 4 hydrogens, 4 hydrogens. 4 oxygens, there's 2 plus 2 is 4 oxygens. This is now a balanced chemical equation. And here is our shining balanced chemical equation for what we just did up there. You must balance an equation before you do anything else with it in chemistry. You can just do a quick check and start looking through an equation. If there are no coefficients present, the coefficients are the numbers in front of the formula, the chemical formula. If there are no coefficients present, it's a good idea to always check and make sure that it's a balanced chemical equation before proceeding with any further calculations. So here are just the steps. This is what we did. Okay, I just wrote them out as steps. First, we read, or you read a description of what you're being asked to write a chemical equation for. It might be written out in words. Then you write down an unbalanced equation. So write the reactants, the products, and their states. Then you balance it. And that's what we did. We balance the equation starting with the most complicated molecule if there is one, and you always go back and check. Always. If you've made any changes at all in your equation, you need to go back and check, make sure that you have the same number of each type of atom existing on both sides of the equation. This is really important. Please do that. So now you get to try one. We have liquid ethanol, right here is its formula, reacts with gaseous oxygen to produce gaseous carbon dioxide and gaseous water. First step, I read it, right? Second step, I write down the unbalanced chemical equation with the reactants, the products, and all of their states. Third, I balance it. So let's do that. Let's start with the most complicated molecule, the ethanol. We have 2 carbons right there, and there's only 1 carbon right there. So why don't we add a 2? Now our carbons are going to be balanced. 2 carbons and 2 carbons. What about oxygen here? You have now 2 times 2 is 4, plus 2 more. That's 6 oxygens. Over here, we have 1 plus 2 more. That's 3. We need quite a few more. Those are kind of difficult numbers to work with. So let's go back and let's look at hydrogens. See if that can make a little more sense first. That might work out better. So here we have 5 plus 1. That's 6 on the left side of the arrow. We only have 2 here. We're clearly going to need to add a coefficient. So if we add that coefficient there, that gives us 6 on this side. Now let's look at the oxygens again. We have 4 plus 3. That's 7 oxygens. We have 1 plus 2. Well, I know if I put a 3 here, that gives me 6 oxygens right there, plus 1 more is 7. Now, last step, important, go back and check them all. 2 carbons, 2 carbons. Hydrogens are 5 plus 1 is 6, and here we have 6. Oxygens, I have 6 plus 1 is 7, and over here I have 3 plus 4 is 7 oxygens on the right side, so they all check out. Now you try one. Here's the problem. Solid potassium reacts with liquid water to form gaseous hydrogen and potassium hydroxide that dissolves in the water. So the potassium hydroxide is dissolved in the water. You are to write a balanced chemical equation for that. So go ahead and pause the video and see if you can do that. All right, here's my answer. First, I needed to write down, we'll read the information and then write down the unbalanced chemical equation. We have solid potassium, liquid water, gaseous hydrogen. Remember, hydrogen's a diatomic molecule, so it's always H2. And then we have potassium hydroxide dissolved in water, so we write the AQ for aqueous for its state. And then I can go back and balance it, and after I balance it, then I need to check it. So let's get to the checking part. Does this all work out? We have 2 potassium atoms on the right. We have 4 hydrogen atoms on the left. We have 2 plus 2 hydrogen atoms on the right. We have 1 oxygen atom, 1 oxygen atom times 2 because they're 2 molecules. So 2 oxygen atoms on the left, and we have 2 oxygen atoms on the right. This is now balanced. So try this one. Under appropriate conditions at 1,000 degrees Celsius, ammonia gas reacts with oxygen gas to produce gaseous nitrogen monoxide and gaseous water. Write a balanced equation for that. So go ahead and pause the video and see if you can do that. All right, here is the answer. Now this one is a little bit more complicated than the other ones have been. We went ahead and write the unbalanced equation for these things right here. And when we look at this, we don't necessarily have one molecule that's a lot more complicated. We can arbitrarily just start with the ammonia gas. So let's do that. And let's look at the 1 nitrogen here. We have 1 nitrogen here. We have 3 hydrogens here, and we have 2 hydrogens here. So we need to shore up the discrepancy, right? If we put a coefficient of 2 here and a coefficient of 3 here, then we get the correct numbers. We have now 6 hydrogens on the left and 6 hydrogens on the right. but we've made a change to this molecule and it affects the nitrogen. So we're going to need to add a coefficient here so that we have 2 nitrogens on this side and 2 nitrogens on this side. So the only atom we have not looked at yet is the oxygen. 2 oxygens on the left and 2 plus 3 on the right. That's 5. Now from math, you know that if you write in a 5 halves right there, 5 halves times 2 is equal to 5. That would give us 5 oxygen atoms on this side, and 2 plus 3 is 5 oxygen atoms on the right side. That would be balanced, but we don't ever leave an equation with fractions in it. We always have only whole numbers as coefficients. We don't ever have anything except for a whole number as a coefficient. So what we can do in this case is that we can take the entire equation and multiply by 2. And when we do that, 2 times 2 is 4. 2 times 5 halves is 5. 2 times 2 is 4. And 2 times 3 is 6. So our balanced equation will look like this with these coefficients in them. So I hope that makes sense to you, and I hope you have fun practicing with a few of these. So we'll see you in class.